Every time an AI system processes a marketing prompt, it consumes time and money. When identical requests hit OpenAI or Gemini repeatedly, we spend 30 to 90 seconds per prompt and pay redundant API fees for copy we have already generated. Because standard large language models lack persistent memory across sessions, they process a duplicate marketing brief as a completely new transaction. Every repetition is a blank slate, incurring the exact same cost and delay as the first attempt. We solve this by positioning Snowflake between the application and the AI models. Here, it acts as an active, high-speed intermediary layer that intercepts incoming prompts. By catching and serving these duplicate requests before they trigger a new API call, we convert an expensive bottleneck into a highly efficient, low-latency pipeline. To build this pipeline, we first set up a data access object, or DAO, within the application. This class abstracts our database connections and automatically initializes our required tables the moment the system starts up. This diagram shows the first structure our DAO creates, the cache table. We use this to store the encrypted cache key, alongside columns for the generated marketing copy and an expiry timestamp. Next to it, we deploy the logs table. This captures the complete lifecycle of a generation event, storing the original input data, any intermediate web search results, the final output, and the total execution time. We isolate these two functions by design. The cache table handles high-speed, transient memory for immediate retrieval, while the logs table handles permanent, deep storage auditing for historical review. Setting up these independent structures early ensures our operational retrieval speeds and our enterprise compliance tracking scale up simultaneously, without interfering with one another. Marketing briefs frequently contain unreleased product specifications, promotional strategies, and upcoming pricing adjustments. Storing these data as plain text in a database creates a massive vulnerability. To protect this data, we enforce AES encryption as a mandatory security standard for protecting all incoming cache keys. The cryptographic process pulls an encryption key from a local variable, passing it through a SHA-256 hash, generating a 32-byte AES key. The cache key concatenates the input, audience, channel, brand, and product. The AES key locks this string, converting marketing data into uniform hex code. This encryption sequence runs entirely within the local application layer. It executes strictly before any connection to the database is established. By enforcing this barrier on the client side, core marketing strategies remain mathematically unreadable to anyone examining the database, even if access is compromised. Retaining old marketing copy creates operational risks. If a short-term promotion ends on Tuesday, an AI pulling cache data on Wednesday might generate copy referencing a sale that no longer exists. We prevent stale outputs by attaching a time to live, or TTL, to every database entry. This enforces a strict 24-hour expiration limit on all cache generations. We implement a cleanup on read pattern. When the application fetches data, the system checks the timestamp. If the 24-hour limit has passed, it instantly deletes the entry. This entirely eliminates heavy background jobs. The application drops the expired data, passing the request to the AI for fresh copy. Embedding this deletion mechanism directly into the read phase guarantees the AI model is never contaminated with outdated business intelligence. When generating marketing copy for multiple demographics from a single brief, a persistent challenge is preventing the AI from reusing the exact creative phrasing across different segments. To prevent repetition, the system scans the cache for previously processed demographics. It retrieves completed copy from adjacent caches and clusters the text. We inject these past outputs into the active AI prompt as negative constraints, dictating exactly what the AI must not repeat. This recursive feedback loop provides the AI with a list of what it has already produced for other segments, allowing the application to enforce creative variation across every audience. Finally, deploying AI in a corporate environment requires meeting a non-negotiable standard: absolute compliance tracing. We begin this process by generating a unique log ID for every run. This ID is created by hashing the complete initial state of the input parameters. Tied to that log ID, the audit log captures highly specific data points during execution. It records the original brief, any intermediate web searches, the exact final output, and the total latency. This diagnostic paper trail allows engineering teams to look backwards. If the AI deviates from brand guidelines or hallucinates, they can pinpoint the exact moment the error occurred and identify the specific data that caused it. We have now constructed a fully encrypted, self-expiring, deduplicating, and meticulously logged intermediary system. Integrating these security and efficiency protocols within Snowflake provides the governance necessary to scale generative AI while maintaining strict control over data privacy and API costs.